Hello and welcome, everyone. Thank you for joining us today for our webinar on empowering collaboration and data sharing, overcoming silos with Quobyte's S3 gateway. In today's session, we will discuss how traditional file systems and object storage hinder collaboration and efficiency in fields where secure data sharing is crucial. Our expert today is Bjorn Kolbeck. Bjorn is the CEO and co-founder of Quobyte, a software-defined storage company that offers a distributed file system designed to provide scalable and high-performance storage solutions for the enterprise. With a distinguished background as Google's tech lead for the Hotel Finder project and as a co-creator of the open source file system HDFS, he brings expertise in innovative storage solutions. Another note for the attendees, we also had Franklin Velasquez scheduled to join Bjorn in the conversation, but due to unforeseen circumstances, he could not join us today. But that's that. And with that brief introduction, I'd like to pass it over to Bjorn so that he can kick off the conversation. Thank you.
Thank you, SK, and welcome everybody. Sorry you just get me today. Franklin couldn't make it. And I'd like to start with a quick intro of Quobyte before we delve into the topic of data sharing. As SK mentioned, Quobyte is 100% software storage. So Quobyte runs on commodity servers with flash drives or hard drives in them. We don't provide the hardware, we only provide the software, and you can run Quobyte basically anywhere. Under the hood, it's a scale-out file system that you can run on Linux servers or the cloud. And I think the focus is that we can think of Quobyte as an enterprise high-performance scale-out file system. Here's a selection of some of our customers. The use cases range from a lot of machine learning AI use cases these days to traditional HPC for supercomputers. So the problem with external data access when you have a file system is that you basically have often high-performance file system in your cluster on site in your data center to provide storage for your compute cluster, for your machine learning GPU cluster, or for your render farm. When you try to share the data externally, there are a few obstacles here. The biggest problem is really that the traditional file system interfaces, the protocols, like NFS or SMB, aren't really suitable for wide area networks, so for connecting over the internet. The biggest problem is probably security. Securing those protocols is almost impossible, so no one wants to open NFS ports to the world. So traditionally you need a VPN access, which means every external collaborator would have to get VPN access, which means a lot of administrative overhead. They need to get an account. They need to install the VPN. Someone needs to help them with that. So VPNs are great for some use cases, but for external data sharing, that's a lot of overhead. The other problem is that you can't trust the external collaborators' desktop or workstations. You have no control over them. So with protocols like NFS that rely more or less on trusted hosts, it's not a good solution. The other option is using intermediate storage. That's something we see more in media and entertainment, using, for example, the cloud. So external collaborators upload it there, and then someone needs to copy it down. But that's a manual task. So it's overhead for people. It's annoying, plus the extra cost of an external storage system, another storage system, of potentially downloading data from the cloud, which always incurs some cost. So in the high-performance computing world, research world, you have often a setup like this. So we have the compute cluster here that is connected to the HPC storage where I have fast I/O. And then you have so-called head nodes that users log into, external and internal users, to access the cluster and also the HPC storage. So the HPC storage is not really shared. So for the external collaborators, that means they need to pass through the firewall to get to the head node. Often that's a protocol like SSH, which is great for terminal access, but definitely not how you want to share files. So uploading files with SCP is error prone. There is no resume functionality. It's very basic. It's not like file system access. And you have the additional copy. So then you need to log into the head node and copy it to the high performance file system. So that's a scenario that we often see in research environments. It makes the data sharing manual and you'd say annoying for the users. The other scenario that I mentioned more in machine learning is when you use an external cloud storage. In that case, you have a fast storage system that connects to the render farm, for example, for virtual effects or 3D rendering, but also editor workstations are directly connected via high-speed links, like 40 Ethernet, 100 Ethernet, to the fast storage. In this scenario, the external collaborators upload the data to a cloud-based solution, Amazon S3, Wasabi, whatever. There are good tools for those S3 uploads. The problem is then someone needs to manually download this onto their workstation and then copy it onto the fast storage. So you have those manual steps and the duplicate copies and the extra cost for the egress charges in the cloud. If you use a provider that has egress charges, and you also need to pay for your own bandwidth. So instead of having this additional step, using S3 gateways allows you to share the data or the file system directly with external collaborators. And there are many reasons why S3 gateways, meaning a translation layer between the file system and S3, is ideal for external data sharing. And I think the most important one is that S3 communicates over HDFS. That's what we all know from our web browser. It's a well understood and very secure protocol. You can install proxy firewalls that can do stateful inspection of the HTTP traffic for additional security. There are load balancers out there for HTTP traffic. So, when we talk about performance, we'll get back to that. So that's easy to do. But the other important aspect is that the protocol has been designed for access over the wide area network, over the internet. So it works very well in scenarios where you have high latencies. So the user might be on a different continent. There might be network interruptions. NFS is probably the worst. SMB is somewhat okay. But when you have scenarios where the network is interrupted for a period of time, maybe because you close your laptop or because you have connection issues, NFS can cause a lot of trouble. S3, on the other hand, is very easy to use and can tolerate that and retransmits. And then you also have tools that can resume transfers, that can do parallel transfers. So it's a powerful protocol exactly for this scenario. And then because you directly communicate with the file system under the hood, you don't have intermediate copies or the extra transfer via an external cloud provider. So you simplify the whole workflow, but you also reduce cost there. So with Quobyte, our S3 gateway is basically a translation layer that we developed from the ground up for Quobyte. So it is well integrated with our file system and creates really unified view. So files can be accessed as objects and vice versa. And if this sounds a bit too abstract, we'll have a demo a bit later to show you exactly what this looks like. And because it's a custom developed translation layer, those S3 gateways, there are no footnotes. So existing volumes can be shared via S3. So it's seamless for all existing data. You can create new buckets that are then accessible as volumes in Quobyte. You can share access control. So this is also unified in Quobyte. So when you set the access control on the file system level, it's also enforced via S3. So it's very easy to keep track of who has access to the data and also audit this. Similarly, access control can be changed also from the S3 interface. So it's really unified, and you can then share the data via native clients for Windows, Linux, and macOS. So across all platforms. The other nice aspect of the S3 gateway is because the data is actually stored in files under the hood, you get the full power of the Quobyte policy engine to control how files and objects are stored. So you can land, for example, small objects on flash, larger objects on hard drives, or have tiering policies depending on your needs. Another important feature is Quobyte's multi-tenancy. That's also integrated. So you can offer storage as a service also for the external data sharing. So tenants or users from a specific tenant only see the volumes and buckets from that tenant. So the same gateways, the same URLs can be shared across all tenants, which makes it very easy to offer storage as a service or isolate different groups and departments. So for the next step, for the demo, we basically have a Quobyte cluster set up. You can do the same. So everything we'll show you today, except for multi-tenancy, works with our free edition too. So you can download it and basically do the demo yourself. One ingredient that always causes some confusion is the proper setup of DNS records. If you use our installer, you automatically get QNS, which is a naming service that we run for you. And that also includes the correct setup of S3 DNS records. If you don't want to use that, then you need something that looks like this here. You need a DNSA record for some URL that points to all the load balancer, the HTTP load balancer, or all S3 gateways. And you also need a wildcard DNS record for anything, basically all subdomains. So this is where the bucket name comes in. If that is correctly configured, your dig response should look like something similar to this one. That's from the demo cluster. So when you ask for a bucket dot whatever, it translates to the S3 gateway domain name, and that one resolves, in this case, to the three gateways that we have here. That's an important step because S3 does not work without the setup. So that's something you need to get right. But as I said, if you use our installer, you automatically have this correctly set up with a domain name similar to this one. And the next step is to show you what this looks like in real life. So let me switch to the demo part. So here you can basically see the demo cluster here set up. So far, we have two tenants configured, and we will work mostly in here, this tenant department A. I have two users, Alice and Bob, ready configured for this tenant. We also have this one here, department B, with the volume exported, published by S3, and you'll notice that this will not be accessible to Alice and Bob. So the first step is to create a volume here in that tenant. I'll just call it data. And then we'll tell Quobyte to publish this as an S3 bucket. So that's an extra step because you can set a different bucket name for a volume. That sometimes makes sense because DNS naming conventions are more restricted than how you can name volume in Quobyte. So the volume name might not be compatible, and then you need to rename it. Here in this case, it's pretty straightforward. So we'll also publish it as bucket data. So the next step is that I have a file system client where Quobyte is mounted. You can see that here. It's mounted /Quobyte. And then I have another client machine with Alice where we will do the S3 access with S3 CMD. Of course, we need to configure that first. And for that, we need to create an access key for user Alice. So to do that, I'll log into the Quobyte user interface as user Alice. So the Quobyte UI has support for self-service and multi-tenancy. Admin Alice. When a regular user logs in, they can basically see what the usage is. So far, Alice doesn't have any data, what tenants they belong to, which groups, and then also access keys. So we can just say create a key here for all users, doesn't expire. Then we copy this information. Also the secret key. No region is necessary here, so we can just leave the default. So the endpoint is where, of course, it's not Amazon. It's the one we configured here, so I can just copy that, paste it here. tool wants this weird information about the bucket names. So that's the default for S3. I think the standard now, the definition by Amazon requires the bucket name to be a subdomain. I don't know why it asks for this all the time. We have to configure it anyways. No encryption. We haven't configured HDFS yet. You can do that in your own environment, use proper certificates or self-signed certificates. For simplicity, we use that out. Test with the credentials, works, save them. And now we can do less. You can see that Alice has access to the data bucket, but she can't see the bucket from the other tenant. Now we can switch to the file system client. See the volume data is here. Let's create a subdirectory. And in that subdirectory, we can create a test file. File. Regular file system. So far, pretty straightforward. And now on the S3 interface, we can list the file, the bucket. When listing buckets, S3 emulates the file system, so it's kind of convenient. We can list the subdirectory, have the test file in here. Now we can download it as an object to the local file system on that client here. The file, we can edit it, do whatever. File. Time. Save this, and then we can upload it to the bucket again. And I'll also add some custom metadata here. The reason is that I want to show you how metadata, the custom metadata that you can set in S3, is presented in Quobyte and on the file system layer. So here in this command, we use S3cmd with put to save it, to upload the test file to this object. And we add a custom header, source US, just something invented, that this data was originated in the United States. Upload worked. So now back on the file system layer, we can just access the file and you can see it's the same data, because basically, as I mentioned, S3 is a translation layer. So when you put an object, it actually saves the new content to the file, updates the metadata, and so on. And talking about the metadata, that is also fully accessible as external attributes. So you can use the Linux tools to get those. Show all external attributes. You can see here that this is our custom one. You also have access to things like the content type, storage class, and other attributes stored by S3. Also the NFS ACLs, but there are better tools to modify these. So another example how this is unified, not just for the content, file content, and the metadata, but also for the permissions. So as I mentioned, you can modify permissions even from the S3 layer. So you can do it via the file system or from the S3 layer. You basically modify the same ACLs. There's just one set. So we can use S3cmd to allow Bob to get full write access to this one object. We could also do it on subdirectories because it's based on a file system. So basically, S3cmd set an ACL, we grant write access to user Bob, which is part of this tenant in Quobyte, to this one test file, test object. ACLs were updated. And now on the file system layer, this NFS4 get file ACL. You can see that user Bob was added here with the full read-write permissions. And we could now modify this from the file system layer, remove Bob again, add other users, and they would also have access from S3. So it's really easy to make sure that everyone has the correct permissions. Also, a major difference here is because we have the file system semantics, you can actually set restrictions or ACLs on subdirectories or on the root. So if you have a volume with, let's say, 100,000, 100 million files or objects, in S3, to change the permissions, you would have to do it on every object or on the whole bucket. In Quobyte, you can also change the permissions somewhere in the path in the file system to then, with one command, change the permissions for all the objects in the subdirectory. So it makes it much easier to keep track of who has access to the data and who doesn't. Another thing you can do is create volumes or buckets from S3. First, I showed you how to create a volume from the Quobyte side, from the web interface. But users can also use S3 command, for example, to create a bucket. This one, Alice data, was created as a bucket, is now available here. And then we go back to the Quobyte mount, you can see also that it's available as a volume. And then, of course, here it's also visible. There's the S3 bucket, no data in there. If you look at quotas, so Quobyte provides tenant quotas that limit everything in terms of size, capacity inside a tenant. And there's, of course, also a quota available for the number of volumes of buckets to make sure that you can limit how many buckets each team or group can create. And then the last aspect that we want to talk today about is the policy rules. I mentioned that the Quobyte policy engine also applies to objects because technically they're files. So you can use the policy engine to design policies that really match how you want the data and objects to be treated on your file system. So one example is that we want small objects and files to be replicated because that's better performance and also more space efficient than erasure coding. But then when we go into the megabytes, tens of megabytes and larger gigabytes, you definitely want erasure coding, especially for S3 because it's the right ones. And this is very easy to do with the policy engine. You can basically just add a file redundancy policy here that is automatic, that does this for you, so you don't need to really configure a lot. Picks the right erasure coding schema based on your cluster size. So anything that's small will be replicated, then it automatically switches to 5+ the erasure coding to save space. So we get that policy name. And then we'll also add another policy. In this cluster, we have enough space on flash, but of course, over time, unused data should be migrated down to hard drives just for cost efficiency. So add a policy to tier to HDD. Here, it's not a global policy, but it should only apply to certain files. And we just base that on last modification age. So anything that hasn't been modified, say, the last 3 days, you can also add more rules and say, this should only apply to files that are, let's say, larger than a megabyte. For those files, we want them to be placed somewhere else after they have been modified for 3 days. And in this case, we change the tag. So instead of SSD, we want them to be stored on HDD. So basically, all new data lands on flash, really great for high performance. Users will love that. And then over time, the files that will, or files and objects will be moved down to the hard drive tier to make it cost effective. Okay, and that's the end of the demo. So we can now open it up to questions.
Thank you, Bjorn. I think this was very interesting. We have a few great questions in the chat window. We'll try to get most of them with the time we have at hand. Number one, how does Quobyte ensure data security and compliance when sharing data across different groups or organizations?
Yeah, so I think this is where the multi-tenancy comes in. When you have multiple groups on the same Quobyte cluster and you want to isolate them, the multi-tenancy provides secure isolation. Then, of course, in addition to that, you have the data encryption feature to keep the data encrypted in transit and at rest. And then S3 itself is, when you have HDFS enabled, is also in transit encrypted.
Thank you. Next one, how does the S3 gateway integrate with existing IT infrastructure, especially in diverse environments like Linux, Windows, and macOS?
Yeah, I think this depends on what you mean with integrate. So if you have users, external users on those platforms, the beauty is that all platforms have great tools for S3 access. I think on Mac you have CyberDuck. On Linux you can use Fuse to mount S3 so it looks like a file system. So there are many options to access S3 conveniently through graphical tools or command line tools. So I think it's really independent of the platform. And probably one of the benefits for external data sharing that it's easy for the admins because they don't have to deal with I don't know, Mac users trying to mount an NFS volume, or even Windows users trying to do that, which is worse. So S3 makes it really easy to use it because you basically give them the access key, the shared key, the endpoint, and then they can get started.
Great, thank you. Next question, can AWS CLI be used instead of S3 CMD? Any differences or limitations?
No, absolutely. I just picked S3 CMD for the live demo because I'm comfortable with that one, and I know it, and I know its quirks. Any S3 tool will work. We regularly test a large number of tools, and we, also make sure that our software follows the S3 documentation. So it's not a standard; it's an Amazon product, and they change the API as they like. And then everyone follows. So we keep track of that too. But most tools just work out of the box. You just have to change if you use the AWS tools, you just have to change the URL from the Amazon endpoint to the one I showed in the demo with your own DNS name, of course.
Thank you. Next question from the same attendee. Can you discuss pre-signed URLs and how Quobyte can support?
Pre-signed URLs, that's a good question. I'm not an S3 expert, so I think we have to take that offline and talk to one of our engineers who knows S3 better. I know that you can do anonymous access to buckets. Pre-signed, good question. We'll get back on that.
Thank you. We will follow up with this particular attendee. Next question. In terms of performance, how does Quobyte's S3 gateway manage high-speed data access and transfers?
Yeah, so the S3 gateways have been designed for high performance and highly parallelized access. So they basically can handle multi-part uploads. They can handle a lot of sessions in parallel, and then have a Quobyte client built in that basically uses the parallel I/O to the file system, to the storage servers. The other aspect is that you can run as many S3 gateways as you like or have the resources for. So if you have a large cluster and you have 100 storage servers, you can have the S3 gateways run on all 100. And then with a load balancer, it's basically as fast as the hardware can go. Our S3 gateways are stateless, so they don't need sticky sessions, multi-part uploads. Each different part can go to a different S3 proxy. So, S3 gateway, they don't have to go to the same one, which makes the load balancing very easy and really means that you can do a scale out here.
Thank you. Could you discuss the scalability of Quobyte's solution and how does it accommodate growing data needs?
I mean, as a scale-out solution, it's very easy to grow a Quobyte cluster. So you can add either drives, if you have open slots in the existing machines, to increase capacity, or you can grow capacity and performance by adding additional servers. That can be done at any time, so it's non-disruptive and very easy. You just install the Quobyte software, configure the registry endpoint, and then the resources are there. Same with S3. As I mentioned, if you install the S3 gateway on each server, S3 gateways and throughput will also scale naturally with the number of storage servers. You just need to add that to your load balancer as a backend list, and then that server will also add S3 performance.
Thank you. We have another question that asks, what about UDP access to the S3 gateway?
UDP access. I don't know. They don't need UDP because HTTP is over TCP, so there shouldn't be any UDP access necessary. Just the one port, which one is it? 431, I think, for HTTPS. That's all you need to open for TCP.
Great. Thank you, Bjorn. Next question. How does Quobyte's S3 gateway facilitate real-time collaboration for teams working on large data sets?
Yeah, I think this is where I showed you in the demo that you can basically access a file as an object simultaneously, upload objects and access them as a file. So instead of copying the data around, as I described earlier, an external collaborator would upload the file. It's on the fast storage on Quobyte immediately. And so let's talk about maintainment workflows. The editor can directly access that file and start playing back, searching for something, or editing it without having to copy it from an external storage onto the fast one. So the copying goes away. If you think about the research use cases, I think in that case, it's even more interesting because it's really annoying as a user when you have the compute clusters and the fast HPC storage is only accessible from that compute cluster because you copied your data set. First, you have to copy your data sets over. So you copy them, I don't know, you tar them up on your machine, you push that tarball via SCP to that head node, and then copy it to a node and untar it. And then if you want to access the result data, you have to do it back and forth. And then you have different versions. It's very annoying. When you open if you use Quobyte as an HPC file system and you open it up to external collaborators and maybe even staff, internal staff, via S3, they can access the HPC storage like a home directory or something. It's very easy. They can copy files. It's very intuitive and easy, and they avoid having copies everywhere. So what we often see in HPC use cases is that Quobyte also, it's not just the fast storage, it's really called data lake, but something that everyone can access from any machine anywhere. And that is just so convenient for the users. And then the S3 access makes that secure and easy also from the outside world.
Thank you. Next question. How does Quobyte handle data redundancy and ensure data integrity across different storage tiers?
Yeah, for the data redundancy, that's what I showed with the policies. So you have full control over how the redundancy is stored or is created, the mechanism, whether you want erasure coding, replication, or the automatic mode that combines it for optimal performance and cost. So that's basically the data redundancy and availability. Also, metadata is replicated 3 times. So Quobyte doesn't have a single point of failure, and that translates to S3 as well. For the data integrity, there are multiple parts here. First, on the file system level, Quobyte uses end-to-end checksums to make sure that the data integrity can be verified and if there's corruptions can be repaired. And then on the S3 level, we have, of course, the S3 checksums that the tools create that are stored in the metadata. I think you might have seen that when I showed the file system external attributes. That's one level. And then, of course, as soon as it's received by the S3 gateway, the data is also checksummed with the end-to-end checksums that Quobyte uses.
Thank you. Last question. I think you also covered it in your demo. Can you detail the process for setting up direct access for external collaborators through Quobyte's S3 gateway?
Yeah, so in the end, that's the external access depends a bit on where your users come from, whether it's LDAP or the internal database or a mix of both. So here in this example, of course, the test cluster has just internal users. So we created user Alice and Bob as unprivileged users. You can easily add additional users here. and then they can either log in themselves or the admin can create the access keys for them from a web console and share that with them. So adding additional users here is very easy. And then you can decide how they map on file system users too.
Wonderful. Well, that's the end of all of our questions. If there's none more from the audience, I think we can conclude. Any parting thoughts, Bjorn?
I think S3 is easy when when you use it with a file system. Once you get over this idea that it's different things, it's just different protocols to access the same data, it's actually a very convenient and secure way to share a file system externally.
Great. Thank you so much.